Okay, so we are in our geometry homework videos. This is chapter 7, problem number 110. It says, carefully examine each diagram and explain why the geometric figure cannot exist. Okay, so let's take a look at these two triangles. If we ignore the angles, it appears that they're congruent, right, by side, side, side. There's a side of 4 that matches up, there's a side of 7 that matches up, and there's a side of 5 that matches up. So based on the sides, they should be congruent by side, side, side. And we know through CP/CTC that if two triangles are congruent, then all their bits and pieces and stuff should be the same as well. But that's not the case, because here the angle in between the side of 4 and 7 is 80, and over here the angle in between 4 and 7 is 50. They don't match up. So there's a contradiction there. The sides say that they should be the same, but the angles are different, so cannot exist. This example over here to the right, we have two triangles which should be congruent. We have a pair of sides that match up, we have a second pair of sides that match up, and then these vertical angles here would create a side angle side relationship. So we know this angle is 50, this angle is 40, so triangle sum tells us that this angle should be 90. But if we do the same thing over here and we add these together, right, 80 plus 50 is 130, which means this angle would be 50. So there's something funky going on with the angles. So the relationships between the two triangles say that they should be congruent, but the angles again are different. So very similar to the first problem there. The sides are saying one thing and the angles are saying another. In this third diagram, based on the markings, these two sides are the same. This shared side is the same, and the angle here are both 90 degrees, which means these two triangles should be congruent by side, angle, side. However, when we match up the additional side, one of them is 12 and the other one is 10. So even though these markings tell us that the triangles should be congruent by side, angle, side, the two sides that are left over don't match up, which doesn't make any sense. In this diagram, these markings tell us that the triangle is isosceles, and if it's isosceles, these base angles should be the same, but they're not. One's 50 and one's 60, so that can't exist. If it's really an isosceles triangle, then those both should be the same. Same thing is going on in this picture here. In fact, it's literally basically the exact same picture as the previous one, just the altitude or height or whatever is drawn in, assuming it's perpendicular. So again, we have an isosceles triangle. These two marks are the same, which means the base angles should be the same, but they're not. They're different, which can't exist. And then in this last one here, we have this side of 15 matches up with this side of 15. We have a shared side here, and the angle in between is the same, so based on that information, the triangles should be congruent by side, angle, side. However, the third side doesn't match up. One is 13 and one is 14, so it's very similar to that example there, where the given information leads us to believe that two triangles are congruent, but then when we look at an additional piece of information, it doesn't match up. So a lot of instances here where we're given information that would lead us to believe the triangles are congruent, but then when we go to match an additional piece by like CP/CTC, we notice that there's a contradiction there, that they're different. So that's why none of those work. And if you have a question or comment about any of those and their validity, feel free to leave a question or comment. Otherwise, you're more than welcome to like, subscribe, or share to our geometry channel.